Welcome, everyone. If you're, like I said earlier, I'm probably going to repeat myself a bunch today, but if you're here right now, you're in the right spot. This is seventh grade Algebra 1. Has a few different names. Some of you may even be confused about that. We've called it different things over the years. When I first started here, we call this the magnet class, G&T, gifted and talented, accelerated a few years ago. Now they're calling it double accelerated. So what exactly does that mean, double accelerated? What it refers to is the idea that you're in an Algebra 1 class. So this is technically speaking, Algebra 1 is traditionally taught at a ninth grade level. It's a ninth grade class, right? If you were to do everything that you're supposed to be doing. And many students don't have the option, and they just take it in ninth grade, regardless of their academic level. Algebra 1 is a ninth grade class, so that's why they call it double accelerated. It's kind of like you're 2 years above. Our school does offer algebra to eighth graders as well. So that would be this, if you're like, what is single? If I'm in a double, what is single accelerated? So there are single accelerated students that maybe don't get into that track that you're in right now, going from sixth to seventh grade. If they do well in their seventh grade math class, there's a certain grade cutoff, just like you guys had, they can go into the eighth grade algebra class. So that would be single accelerated. And then if you don't, there's just eighth grade math, just like there's seventh grade and sixth grade math. So that's just explaining the courses a little bit. If you're confused, like, hey, where am I? Am I, you're not familiar with the names and what this means and all that stuff. That's Algebra 1. So like I said, this is our first session. Today's date is August 6th. The remaining 3 sessions, there's 4 in total, are each going to be on a Tuesday. So for the next upcoming 3 weeks, the 13th, the 20th, and the 27th, will be meetings using the same Meet link on Google Classroom. I'll go over a little schedule and agenda on this next slide here. And yeah, we'll get going. But welcome, everyone. My name is Mr. Rice. You've probably seen me around the building. I know most of the 6th graders last year, I think every 6th grade class had 6th grade math on the 3rd floor, probably right across the room from me or a little bit down the hall with Miss Mavro. Or who were some of the other 6th grade teachers? Why am I blanking? We had Camerata. Yeah, Camerata's right across the hall from me. So Camerata, Mavro, I think that's it, right? Maybe there's another teacher I'm forgetting. But yeah, I'm room 323, so that's the room we'll be using. Basically, when you walk up the main stairs, the classroom right in front of you there, right across. I'm on like a diagonal from Miss Camerata, and a little bit further down from Miss Mavro. Right next to Mr. Knuckle is another way to remember. All right. So a little agenda for today. I already kind of talked about the first bullet point. What does double accelerated mean? What does regents mean? I do have a few other points there. We'll talk about materials for the school year, the big one being the graphing calculator. That's something that people have a lot of questions about. It's expensive as well. Our schedule, it's going to be, it's easy to remember. It's the same time. It's Tuesday for the next, 4 weeks in a row, basically, right? 3 after today. There will be recordings and that's. We'll just ask some questions before we get started. Today's lesson is going to be on polynomials. It is difficult to do. Think about it from my perspective, right? It's like, what are these 4 sessions going to be? Am I going to teach all of Algebra 1 in 4, hour-and-a-half sessions? No. This summer sessions is basically to get you ready for the upcoming school year. Basically, bridge the gap. You're going from 6th grade math. And I know Miss Camerata and Miss Mavro, after the state test, they did a nice job doing some spicing it up a little bit, doing things to get ready for, basically next year and beyond. I think graphing you guys did and stuff like that. So what these sessions are going to do is bridge that gap, help you kind of transition from hey, I was in a 6th grade math class last September, and now I'm in a Regents level course. Okay, it's not going to be scary. Don't worry if you're like, oh man, I don't know if I could handle this. It's going to be tough. As long as you, kind of do everything that sounds very cliche, but as long as you do everything that you're supposed to be doing, pay attention, ask questions, starting in these sessions, starting in the school year in September, it's really not that bad. I wouldn't lie to you. I wouldn't be like, hey, this is the hardest class you're ever going to take. It may seem like that at times, especially early on. But if you do everything you're supposed to do, very cliche, very basic saying, but you'll do very well. And then towards the end of today, we'll do some practice and review. I saw in the chat someone asked a question about delta math. Yeah, so I did post some information. I'll talk more about that again as well. But delta math, let me ask you guys in the chat, how many people used delta math before I posted about it, I think a week ago? How many people used it? I'm not sure if the 6th-grade teachers used it. Yeah, it's not really meant for, so it's not like you were missing something. But I use delta math for basically kind of what we're going to be using it over the summer. I do homework on there occasionally, classwork. It's good for drill and practice. So they do have like word problems on there, but it's not really amazing for that. It's good for the stuff where it's like, hey, I'm struggling with solving equations. Delta math can have, an unlimited bank where you can just practice that. So it's good for that type of stuff, the black and white, just arithmetic, algebra stuff. It's really nice for. Because hey, you learn a new skill, you're like, I wanna practice with this. That's where delta math really shines. Tells you if you got your answer right, shows you how to do it, versus just like, hey, here's a textbook, do a million problems, and you'll never really know if you got it right. But if you're like, hey, I have no idea what you're talking about, on Google Classroom, you might have to scroll down a little bit. There's information about how to sign up. And towards the end of our meet today, I'll go over that again. I did make a delta math is basically organized by classes. So right now everyone's in, I just called it like summer class or something. So when we start the school year, I'm going to delete that or archive it, and you'll be asked to sign up again the first week of school. This way I could have you guys in, I don't even know the class numbers they're using. I don't know if you guys know, probably 722, 721 or something, whatever numbers they use. I'll reorganize it. So it's a little annoying, but hey, we'll use it for the summer. We'll archive that class, and then you'll be asked to sign up again in a few weeks. All right, so a few more pieces of information about this being a Regents class. Because this is a Regents class, you will not be taking the math state test in April, May, like you have been since 3rd grade. What I mean by that, every April, May, usually the ELA test is in April and the math is in May. Sometimes they vary a little bit. You start that in 3rd grade, 2-day exam. It used to be 3 days back years ago. You'll still be doing that for ELA this year, but during the math state exam, right, you won't be doing anything. We do other things. We do some like practice, mock Regents type stuff, but you won't be taking the math state test. Instead, you'll be taking the Algebra 1 Regents exam, which this year it was on the earlier side. Usually it's in the middle of June. This past year, it was June 4th. So it was a little bit early. You'll be taking 2 Regents exams this year. One of them will be in math for Algebra 1. The second one will be Earth Science with, I believe, Mr. Rankin you guys have, or will have. So that's something we'll be talking about as the year progresses and the year goes on. The Regents is a little bit different. You get a numerical score out of 100, so more of a traditional test. Whereas with the state exams, you've gotten like level 4, level 3, 3.8, 4.2. The Regents, you get, hey, I got a 91, I got a 95. There is a curve, there is a scale. It's a 1-day, 3-hour test. So don't stress about that now, but just wanted to bring that up. We do plenty of review for it. Students do very, very well in the the 7th grade algebra class. This isn't an issue of like, usually early on in the year, people are like, oh man, I'm going to fail the Regents. No one even gets close. Everyone this year got above an 85, just to give you a frame, point of reference. Yeah. So materials for the upcoming school year. First thing I want to talk about, the graphing calculator. It's a little blurry. Oh, actually, not too bad. Graphing calculators. The TI-84 plus CE is going to be the most common one. Any TI-84 does work. Sometimes I'll usually have like 1 or 2 students every year that has like the TI-84 just regular, TI-84 plus. They were just a little bit bigger. These ones are thinner, they're in color, nothing really that mathematically different. So any model TI-84 does work. These are the ones you're probably going to see in the store. They are expensive. They're around $100 plus, depending where you look. Amazon, Staples, I don't know what other stores have them, Target, things like that. Around $100 plus, 120. However, this is the last calculator that you're going to buy. So, I got a graphing calculator when I was your age, middle school. I still have it. So you use it all through high school, all through your college classes. So it is a little bit of an investment, something you can hang on forever. Being that they are expensive, you want to make sure you label it, put your name on it, write it on Sharpie. There's a case, put your name on the case and the back of the calculator itself. Because think about it, there's going to be hundreds of students in your school that have a very similar one. Even if you're like, hey, let me get these come in different colors. So like, hey, let me get the pink one. No one else is going to have that. There will be other students that have it. Just make sure you label it, put your name on it. We don't want anyone to lose them, because it's like losing, not quite as dramatic, but it's like losing a phone or something, right? It's an expensive piece of property. We do have class sets of these. So if you've been in my room, I know some of the people in here are on math team. I don't believe Miss Conrad or Miss Mavra had them in my room, but we have these like yellow trays of them. So I have around 30 plus in my room, the little charging stations in the front of my room. So you might be saying, hey, why do I need to buy this if you have them? Because we use those during the actual class. Let's say you forgot yours at home. Maybe you never want to bring yours into school and you just want to use mine, which is fine. Those are like school use calculators. Your calculator would be for, one, if you just want to use your own and you're like, hey, I don't want to use yours. And 2, when you're doing homework, when you're studying at home, this way you have a device with you. You don't need them for these sessions. So if you like ran out late last night to get it, great. But it can't hurt. I'll go over maybe a few things with it, a little bit of an overview. But more so for like the first week of school. Some people take a little time, it's fine, because like I said, you could use the school one in our class. Any questions with the calculator before I move on? Questions? Calculator questions? I'm also going to take my headphones off. Calculator questions? No? All right, so we talked about our schedule already. Like I said, this meeting's being recorded. I'll post it on YouTube and post a little link eventually. Hopefully the other ones will be as well. Like I said, sometimes things do happen. It's a large file. I don't know, could get lost. So worst comes to worst, annotated notes, like my notes with my handwriting. I am sharing my iPad right now, if you guys didn't realize. Will be posted, so you can look those over. If you know ahead of time, like, hey, I'm not going to be able to make next week, that's perfectly fine. Hopefully you'll have a video and some notes to look over. I'll take another little quick pause here. Any questions? I know I'm talking a lot. Hopefully it's not too overwhelming to start, but any questions? We're good? 57 people in here, nice. So like I said, today we will be going over polynomial stuff, some exponent rules, basic polynomial operations, multiplying polynomials we'll get to towards the end. One thing that's going to be common as well, think about it, there are 3 classes this year, if you guys are unaware of that. So last year, for example, I taught the 7th grade double accelerated. There's 2 classes. 722, and 728. Like I said, I'm not sure what numbers they're using this year. I don't think they're using 28, maybe 20, 21, 22, or something. Um, there are 3 classes this year, so there's around 90 of us, uh, all said and told. We have 57 right now, but um, everyone's coming in from a different level, right? I know everyone, for the most part, was. I don't believe this would be possible, but everyone was in a 6th grade class last year, right, with Miss Marlborough, Miss Camerata. I think that was it. So everyone is coming in from a different level. So we might start talking about some of the stuff today, and you're sitting there like, "Oh, I know this. I know this." That's great. Congratulations. Awesome. But what I'm trying to do is hit some of the core topics here. Like I said, I'm condensing some of the pre-Algebra 1 stuff into these 4 sessions. I picked things that I found that were the most beneficial to help us out to start the year, right? I didn't say, hey, let me pick the hardest topics. And like I said, these are a little bit of like a pre-Algebra 1. Will we talk about them again during our actual school year? Yes, but maybe a little bit spiced up. So this is like a little bit of a preview, a prequel, whatever you want to call it, of some important algebra skills. Like I said, starting with polynomials today. If you have a piece of paper, pencil, notebook, that would be great for these as well. I didn't mention that. Do you need to copy notes? You can if you'd like. I'm going to have them up more so as a talking point for me. Again, these will be posted, so you could always just view those and copy it down. If you want to just have a notebook, some of you maybe already do, that's perfect as well. Definitely for practice problems as well. I'm going to put a problem up in a little bit and say, hey guys, try this one out on your own. So having a piece of paper in front of you would be a good idea. All right. And yeah, we'll get started here. One question I always like to ask makes me feel very old as well. Any students in here that I had a sibling, older brother, older sister, maybe a cousin? Anyone in here that I taught your sibling? This is my 10th, I'm up on my 11th year at MS67. So very likely. Okay, the 3 classes are 20, 21, 22. Thank you. Alyssa says, my sister. Who is your sister, Alyssa? Oh, wow. A lot of people. Okay. Gabriella, I'm going to guess your brother's Josh. I recognize the last name. Alyssa, I'm not sure who your sister was. Abdul Khan. Who's your brother, Abdullah? Kayun's sister. Okay. Iris, who's your cousin? Ashley. What's her last name? Ashley Shah. Okay, yeah, I had her last year. But yeah, I'm sure there's a few others as well. Maybe some people are in here. Usually there's a good handful that I've had. Like I said, this is my 11th year. I do traditionally teach this class, the algebra class. So I've done it a lot. Other classes that I teach, I will be teaching the Math 7 class as well. 1 class of that. That's so you'll have friends in there, I'm assuming. That's just the regular 7th grade math. Like last year, you were in regular 6th grade math. So I teach 7th grade across the board, 3 of these algebra classes, and then 1 Math 7 class. I've taught 8th grade in the past. Years ago, I taught 6th grade, accelerated, 6th grade G&T, I guess. I don't know what they used to call it. All right, so let's get started. No questions about calculators. Usually I get a bunch. How many people have this already? How many people have a calculator? Like, hey, I saw your post a few days ago. I got it, or I got it. I have older brothers. Wow, a lot of people. Awesome, awesome. Yeah, sometimes people even almost get like I don't know what to call it, like a hand-me-down. Like, hey, my brother or sister is a few years older. They don't use it anymore, so I'm using theirs. Those are usually people that have like the older ones. When I was in school, they were TI-83s, which if you Google, it's basically the same. They haven't really changed much. It was just kind of more pixelated, a little harder to see. They made the screen a lot more clear. They made it a lot more user friendly, thinner. But yeah, they all do the same thing. What we're going to use on it, if you have a slightly older model, it's perfectly fine. What not to do with this, and this happen usually there's like one kid every year. Hopefully this doesn't happen this year. That will get, maybe their mom or dad went to the store and didn't really know. That's why I try to take my time and explain it to you guys. And they'll grab, because sometimes in the store it'll be labeled. It'll say graphing calculator, and it's like a Casio, weird model calculator. Um, it's a calculator, I suppose, but it's not the one that we're looking for. It's going to be very confusing if you use that throughout the year because, and I have an emulator on my laptop, something that I can share, screen share when we're in the room, show you guys, hey, we're using these. Some of the things are a little complicated on here. Hey, hit this button, hit this, enter this window. If you have a really weird model calculator, I can't really compensate for you. I'm not going to say, hey, let me do a lesson with everyone and then I'll come over to you and talk for 10 minutes. So that's why we really want to stress getting, being all on the same page. My dad used the TI-83. Yeah, that was the standard for a while. If you don't have one, it's fine. Like I said, you definitely don't need it. You definitely don't need it today by any means, but like the first few weeks of school, I'll have them in my room for class, but homework wise, you would need it. You know, you would first few weeks of school, perfect fine. All right, but let's get started. So if we're going to talk about, how am I doing on battery? If we're going to talk about polynomials, we do need to talk about our three basic, I just call these very kind of straightforward, our three basic exponent rules. Okay. Like I said, with notes, kind of do what you feel. If you're someone that likes to take notes, you have a notebook in front of you, great. If you want to kind of just pay attention, that's also fine. I'm going to give more so an explanation here. I'm not just going to be like, hey guys, copy this down and let's move on. So I'm going to explain it. I more so have this up for me, but if you want to copy it, that's perfectly fine. So getting back to my point, if we're going to be doing operations with polynomials, combining them, multiplying them, all that fun stuff, we need to know these three basic things. And there's a lot more, not a lot more, but there's a few more rules. But for now, we'll stick with these three. We have a multiplication rule for when dealing with variables and exponents. We have a division rule, and we have a power rule. Sometimes we'll call this a double exponent rule. But three main rules for how to handle variables and exponents. Or just exponents in general, I guess, because these do apply to numbers as well. All right, so our multiplication rule says when multiplying for variables that are the same, we add exponents. So I'll give a little example here. And like I said, especially starting out, a lot of you guys will recognize this. Like, hey, I've seen this before. I know how to do this. That's great. In this case, if we're doing x squared times x to the fifth, okay, we could do something there. No, I can't sit and type that into my calculator, but I could manipulate the exponents to kind of simplify this, right? I could state that this is x to the seventh. What I'm doing there is adding my exponents together. And I'll go into a little reasoning of where this stuff comes from. Obviously, a very common mistake here. What do you think would be like a good wrong answer? If I had a multiple choice, maybe the first, a quiz where people learn this for the first time, what do you think people would mistakenly say? Very good. Yeah, x to the 10th. It kind of makes sense too, right? Seems that's like what it should be. Like, hey, I'm multiplying. Why don't I multiply the two numbers, right? I'll put put a little X through this so we make sure we know that that's not the answer. So why is it not that, right? Why do you actually add exponents? Sometimes in math, we do this thing where we just, we take it at a base level and like, all right, that's how I do it. Cool, let me move on. But it is important to understand where some things do come from for a variety of reasons, right? It helps you understand it better. Just kind of nice to know these things. So where this comes from, the best way of thinking about it is what these exponents actually represent. X squared, what that actually is x times x, right? That's x squared. Just like 5 squared is 5 times 5. X to the 5th is, same idea, 5 x's consecutively, right? This is, do we all agree that's x to the 5th? Now, if we look at this as a whole, right? Drop those parentheses there, I suppose. What do we have? We have 7 x's in a row being multiplied, x to the 7th. So that's where the adding comes into play. If you've seen this before and you're a little confused, it kind of has to do with like grouping things together, almost like counting. Okay, I have 2 of these, 5 of these. I have 7 altogether. Do keep in mind that this only works for when the variables are the same, or the numbers are the same, whatever the base may be. If this was x squared times y to the 5th, there's nothing I could do there. So this only does work when the variables are the same. Okay? The division rule. When you're dividing like variables, like bases, you subtract exponents. And that little abbreviation at the end says, or it's abbreviating, numerator minus denominator. Okay, so I'll pop up a little example here. Let's do this. Again, your brain really wants to do this a certain way, right? That is it. I'm putting a little fraction bar to signify division. You could put the little old school, division sign if I want. Your brain really wants to divide. And your brain really sees division, it sees 2 numbers, it sees sometimes it sees something that goes into something else, right? In this case, 2 does go into 8. So your brain really wants to say x to the 4th. However, anyone what's the answer here? X to the 6th. Very good. And it kind of goes hand in hand if you think about it. When we're multiplying, we add exponents. When we divide, we subtract. Kind of makes sense, right? Usually when one goes into the other is where people would make that mistake. Because if it was like x to the 8th over x to the 3rd, you would probably catch yourself if you were confused. Because you're like, wait, 3 doesn't go into 8. Oh yeah, I subtract. But it's cases like this where it goes in that someone would quickly maybe circle a wrong answer or do a wrong calculation on an assessment on a test or quiz. Where does this rule come from? Should have chosen a number smaller than 8, but x to the 8th, we have, that's 7. I have 8 x's, right? I have 2 x's in the bottom. And this rule comes from almost like, this is not a great math vocab word, but canceling, right? I could cancel out these 2 x's. X divided by x cancels, it's 1, right? I could put a slash through them. I could do that again. Can I do that any more times? No. So what am I left with? 6 consecutive x's being multiplied together, or x to the 6th. So our division rule comes from this canceling idea. That's where the subtraction comes into play. Just like the multiplication rule dealt with like a grouping all together, and that's why we added. Division deals with subtracting. Okay, doing good so far? And last one, our power rule. Sometimes I'll call this a double exponent. This one we do actually multiply. So if we have x, if we have something like, this is just a textbook definition, but if we have like x to the second raised to the 5th power, let's say, I could just very simply make that x to the 10th. And you can see why I call this a double exponent. Okay, it's one exponent. Let me get my laser pointer. It's one exponent and then raised to an additional one. Okay, x to the second raised to the fifth would equal x to the 10th. So that starts to make things a little confusing. Reason being, we just said earlier the multiplication rule, you don't multiply, but now there is one where we do. I would remember this one as just kind of like, it looks like multiplication one, right? Two things next to each other separated by parentheses. We can explain where this one comes from. I'm going to use smaller numbers. Let's say we have x to the second raised to the third. What that is 3 groups of x squared, right? And now we can go back to our first rule. So it's kind of connected back to our multiplication rule. Going back to our first rule, we learned that we could add these together. And that gives us x to the 6. Or more directly, you could just multiply those two numbers. All right, I'll zoom out here. For a moment. Any questions with our 3 rules? Like I said earlier, let me get this out of the way. That doesn't help. This is going to be our foundation for all of our polynomial kind of operations that we're going to be doing today. So while some of you may be comfortable with these, you've seen them before, that's great. I wanted to make sure that we're all on the same playing field to start. Any questions with these 3 exponent rules? Take a moment. Questions, don't understand something, you've never seen it. We're okay with these? Yes? You don't need to know, like I mentioned earlier, with a lot of topics, I like to show the behind the scenes. Hey, this is where this came from. Hey, this is why we do it. If that's throwing you off, that wasn't my intention, was to make it make more sense that way. You don't need to, know that explanation or know the behind the scenes. I like to include that with a lot of my explanations just to kind of show you. But if that, for some reason, if that was detrimental, if that confused you more, and if you just want to take these at surface level, that's fine. But hopefully that explanation helped out. Good? Yes? Okay. The next thing that we're going to talk about, I'm more so going to write here. I call this is another thing that's going to come into play with polynomial operations. I call this CLT. That L is a little thin. It looks like it says CI, but CLT, which abbreviates or just an acronym for combining like terms. How many people, you could raise your hand, type in the chat, know what this is talking about? Obviously, there's no notes or practice here. Like, all right, I did this. I know what you're talking about. I know what you're getting at. So I'm seeing a lot of people saying yes. So that's why I did leave this one blank, not because we're going to skip it, but I'll do a quick little overview. I know you talk about this a little bit in 6th grade. Hopefully, this is something that, and if you're sitting there like, hey, I never did this, that's fine. We will talk about it as well. Does anyone want to explain what combining like terms is, how it works? Type in the chat, turn your mic on. Go ahead. I thought someone was talking. Go ahead. Someone has their mic on. I can't see who it is. Maybe not. So we'll start with the very basic stuff, right? Combining like terms deals with kind of like, it's almost like a matching game, right? All right, 2x and 3x, I can combine those together. We all know this, to 5x. We don't touch the exponents at all, so don't start to confuse this with what we just talked about on the last slide. Like, oh, let me make this 5x squared, because no, this is just a grouping idea, right? It's counting. Hey, if I have 2 apples and then 3 more apples, I have 5 apples, right? We cannot combine like terms if they don't match. So there's nothing to do there. You can't make that 5xy, 5x, 5y, I don't know what else, but you can't do anything. So if you don't have like terms, just like if you said, hey, I have 2 apples and 3 oranges, there's nothing to combine, right? Those would be what we call unlike terms. There's nothing you could do. There's nothing you can condense any further. Now, variables also get into play here. Exponents also come into play. So let's spice it up a little bit. Okay, zoom in on this one. So everything does have an x here, correct? However, not everything is a like term. The like terms would just be 2x squared and 6x squared. So it's really a two-piece idea. I don't know how much of this you cover in 6th grade. Maybe you just deal with the variable component and you don't really touch the exponents. But it's really a twofold idea. The variables have to match and the exponents have to match. The number in front, the coefficient, not as important, because that's what we're combining. What has to match is those secondary ideas, the variable and the exponent itself. And the other like terms we have, I can combine 5x, and we'll talk about that in a moment, what that is. But combining these, we have 2x squared and 6x squared. If you combine those, add those together, you have 8x squared. 2 plus 6 is 8. You just leave the secondary part. You leave the variable and the exponent. So no touching that. You don't make it x to the 4th. When you're combining like terms, you're literally just adding the numbers in front, what we call the coefficient. And now for the second piece here, we have 5x, and I'm not going to treat that like an x. First of all, what's the number in front of the x? If you don't see a number in front of a variable, what number is kind of hiding there? 1. I'm not going to treat that like a 1 and say 6x. Being that it was subtraction, I'm treating that like a negative 1, really, right? So 5 minus 1 would give me 4x. So the sign in front, and that's our final answer. There's nothing else I could do here. The sign in front does matter. Notice when I highlight, and we eventually, oops, someone's trying to get it. When I highlighted, the 4 terms here, included the sign. Okay, that is going to be important. The positives obviously didn't really change much or move the needle, but the negatives I would definitely want to highlight that. I would definitely want to include that. This way I don't mistakenly add 2 things that I really should be subtracting. So subtraction and negatives are going to go hand in hand. Does that make sense? And like I said, that would be it. I can't take this any further. I can't do this. I can't say, hey, that's really 12. No, nothing else I could do, because they have to have the same variable and the same exponent for you to be able to combine them. Does that make sense? So we'll say like terms, same variable and same exponent. If that's the case, you could add coefficients or subtract if a negative is involved. Can't you simplify it by finding a GCF? That would be a skill that we call factoring. That wouldn't be simplifying expression. That's actually breaking it apart. Like, is there something to do here? Yes. You could factor out a GCF if you wanted to. However, would that really help us in the cleaning up portion of it? Not really. It's just an alternative way of writing it. Factoring is breaking something apart, right? Like factor the number 10. You could say 2 times 5. Did that really help you simplify it at all? No, it just changed the way it looks. But good point. Factoring is going to be a major skill. That's a topic that people tend to not like in algebra. I like it. Factoring polynomials. Maybe we'll talk about it during one of these sessions. We'll see. And it's not just GCF. There's other skills that you haven't learned yet, like how to factor trinomials, sum product rule, things like that. Okay. Questions with this slide? Do we all feel pretty confident so far? We're doing okay? Let me double check. Is anyone having an issue getting in? Okay, we're not going to do that. So I don't. Does anyone know Nathan? He just got removed from the meet, and he will not be attending any other ones. We're doing okay? All right, let's move on. All right. Might want to skip this. And we'll talk about it. Okay. Don't write anything down here if you really want to. Go for it. But we literally have a unit this year in algebra called polynomial. So I do feel it important to be like, hey, what does that word mean? First of all, the prefix poly means many. Okay, you might have heard of a binomial, which is 2 terms. A trinomial is 3 terms, right? Saying poly just means many. It could be one. So it's just kind of a general term of saying like a math expression, right? There are some rules for it. You can't just put down random things and be like, here's a polynomial. So there are some rules. Maybe this is something new for you. You've said that word a lot of times, but you didn't really know what it meant. A polynomial is an expression containing variables, constants. Constants are just numbers, and or exponents. A polynomial can be one term, or it could be a sum of difference of multiple terms. Some of the rules for what a polynomial can't have, it can't have a negative or non-integer exponent. So I'll zoom in to these non-examples. Because that looks pretty good, like that 3xy, that's to the negative second power. It looks like, a math expression. It's not a polynomial because it has a negative exponent. So exponents can't be negative, and you can't have any sort of fractional exponent either. So if you have like x to the 1/2 power, which really means the square root of x, not a polynomial. Okay. The second one, you may be curious why that's not a polynomial. Being that the x plus 2 is in the denominator, that's really like being raised to the negative first power, which we'll talk more about. But just be aware that there are some rules for what makes something a polynomial or not. Okay. Like I said, it can be something simple as one term. So just say the number 5. Okay. That is a polynomial. Poly does mean many, but a number just by itself, a variable just by itself does work. Now, another thing that you're gonna hear a lot, maybe you've seen this phrase, you've heard this expression before, standard form. Usually this will be in the instructions for a question, right? Hey, do this and write your answer in simplest form or standard form, right? So there's a rule for that as well, how that works. So what standard form is, it means the variable with exponents are written in a descending order, starting with the highest degree and ending with the constant term. That sounds really fancy. What that basically means is the higher your exponent, the more precedent you have in the answer. So like x to the third should come before x to the second. And x to the second comes before just plain old regular x, right? The higher exponents come first, almost like boarding a plane, how they have like group A, group B, group C, or whatever they call it, right? The higher your exponent, the more priority you have. You come first. Okay? What degree means, we'll go over some vocab as well here. Degree is just the exponent. So degree is another way of saying what the exponent is. So in this term right here, the degree would be 3. You'd say degree 3. Basically a way of just saying like, hey, what's the exponent? Now, the other thing that standard form includes is combining like terms, what we talked about in the last slide. So if a problem, a practice problem says, hey, write your answer in standard form, it's saying two things. Clean this up as much as you can, condense it, clean it up, do what you got to do, and then make sure that you're writing it in this specific order. Okay? Does that make sense? So what we can do here, let me erase where I wrote degree. Does anyone see anything that I can combine first? So we'll do all the combining and then we'll do the order as well. What can I combine here? Yep, I can combine 6x squared and 4x squared, right? I'm going to start with the x cubes actually. So I'm going to combine 12x cubed and 5x cubed together. Now, if I combine 12 and 5 x cubed, that's going to give me 17x cubed. Why I started with that one, I knew that was going to be my first term because like we said, the highest exponent comes first. So when I'm playing the combining game, I'm going to kind of kill two birds with one stone. I'm going to start with the one that I know comes first. This way I don't have to worry about the order. Next, I see a 6x squared and a 4x squared. If I combine those together, I get 10x squared. What I like to do sometimes, I know earlier I was, I have highlighters and colors here, but most of the time we just have a pen or pencil on us. When I'm matching up like terms, I'll add different amounts of lines underneath because you could do this, with one color. You could do this as many times as you want. Some people, I don't know what your sixth grade teacher taught you, they'll do different shapes. The only problem with that is you kind of run out of them. You do circles, squares, and you kind of run out pretty quick. So I like doing lines instead. And minus 3x is just going to stay minus 3x. There's nothing for me to combine. So that's just going to stay as minus 3x. And now my answer is in standard form. Again, that's two things. I cleaned it up as much as I can. There's nothing else I could do here. And it's written in a specific order. The order here is the idea that the exponents start with the highest and work their way down to the smallest. You might not have every step along the way. Like if I have an x to the fifth, that doesn't mean there's a fourth, a third, a second, a first, but it does have to go in order. So you have to start with the highest and go in order from there. Okay? It says with a constant term on the end because if there is a number in the problem, let's say there was like a +7 here, right? That technically doesn't have any exponent at all, so that would always just occur at the end. So if there is a constant in the problem, you know that's going to come in last place. We'll zoom out. Questions before we get into some actual polynomial operation stuff? Questions? What if there's two constants? You can combine them. So you can combine constants. Constants are just numbers. So if there was a 7 and a 5, you could be like, all right, that's plus 12. And that goes on the end. What if some terms have multiple variables? Good question. We're not going to really see that much this year, but with multiple variables, the same things apply. So if you have like 2xy and 3xy, you can combine those, but your exponents still have to match. If you have something like this, you wouldn't be able to do anything, whereas the top one, you can make that 5xy. Oh, alphabetical order, thank you. What that meant was, let's say there was this isn't as big of a deal. Let's say there was a y to the third in this problem, randomly, right? We said your exponent decides your order. So technically, there's like a tiebreaker here, right? We have a x to the third and we have a y to the third. So which one comes first? Not a major deal, but technically alphabetical order is the tiebreaker. So in this case, we would put 17x to the third, and then we'd put plus y to the third. So the exponents decide your order. And then if there are two of the same exponent with different letters, like an x squared and a y squared, an A and a B, right? Alphabetical order is the tiebreaker. Not a major deal. That's not as important, but just a technicality. Questions with this slide before we moved on? Some good questions at the end there. Feel free to ask, guys. I know no one wants to ask questions, especially early on. But feel free to type in the chat, turn your mic on, ask. I always say in math class, if you feel like you have a question and you're at that point in your head where you're like, oh man, I don't want to ask because it seems like everyone else gets it and I don't. There's probably 10 other people that have the same question as you. They're all thinking the same thing, right? So never feel embarrassed. Never feel like you don't want to ask something. Good. All right. So we'll jump into some actual practice problems here. I'm going to zoom in. I put these all on the same page. It might be a little too overwhelming to look at it as a whole. So I'm just going to zoom in on this. If you have a piece of paper, a notebook in front of you, which, like I mentioned earlier on, is a good idea, copy this down. This is the first thing that I'm telling you to copy down, starting with where it says, where it says 5 all the way to where it says +3 parentheses. Copy that down. What we're going to do, I zoomed in just to make it clear. I'll explain what the instructions said. The instructions here were basically to clean this up. It says simplify, and write your answer in standard form. So notice we are going to be doing some distribution, another topic that you guys dealt with this year. Everyone here did distributive property. We should know how to distribute. There is some negative sign stuff that we'll talk about, but we're going to clean up this expression. Copy this down. We'll do this one together. All right. So what I want to do first, well, can anyone tell me, what should we do first? What do you guys think? Go ahead, Ethan.
Distribution.
Very good. If you have a problem that you're cleaning up, right? Sometimes, especially when, hey, we just talked about like terms, sometimes people might do this. They might be like, wait, I see a 6, then I see an 11, that's 17. You can't do that until you've taken care of all the multiplication. Because think about it. Go back to PEMDAS, right? Order of operations that you did in elementary school last year, maybe. Distribution is multiplying. Combining like terms is really like adding, right? Can we add things together before we've taken care of the multiplication piece? No. So combining like terms doesn't occur until the end. That's like a closing move. Like, hey, let me start combining. That's not an opening move, unless that's the only thing in the problem. So in this case, we do want to do our distribution. I don't know about you guys, but when I distribute, I like to draw my little loops. This serves as a reminder of how many times I'm multiplying. In this case, I'm multiplying a total of 5 times. So our first distribution is going to become 5x cubed. That's 5 times x cubed, right? Just basically glues in front. And now 5 times 6x would be 30x. Now, this starts to get a little tricky. We have negatives, not our friend. A little confusing, right? We have really a -3 that's going to be multiplied. So we're going to do -3 times x cubed. We have -3 times 11x. What would that be? That would be -33x. And then -3 times +3 would be -9. Okay, that's after distributing. Now that we've taken care of all the multiplication, now we can finally say, hey, let's start combining things. Does anyone see anything we can combine here? What could you combine? Does anyone see any like terms that they could match up? The x's. Okay, yeah, good. So I'm going to start with the higher exponent here. So I'm going to start with 5x cubed. I can combine that with, remember we said earlier, you want to make sure the sign in front is incorporated. So 5x cubed and the -3x cubed are going to combine. So what would that be if I combine those two together? Not 8, but 2. Very common mistake. People just kind of see the numbers and start adding things, right? The sign in front does indicate whether we're adding or subtracting. Next, people were saying 30. I'm going to put 2 lines under these. Like most things, being neat is very nice here. If you just start kind of scribbling everywhere, it's very easy to make a mistake. It's easy to forget a sign, miss something. So here we have 30 minus 33. That would give us what? -3x, very good. And last one, we just have the constant. This is going to happen when you're combining like terms. Not everything's going to match up. So sometimes you're just left with something. Sometimes maybe nothing combines. So in this case, our final answer would be 2x cubed minus 3x minus 9. Okay, questions with that one? Good. I want you guys to try the second one. I'll write it out for you. We're randomly using variables here. Sometimes with polynomial questions, they'll do this. They'll be like, hey, call this one A, call this one B. It just makes it simpler when they're asking you to do maybe a series of operations with them. I might say something like, hey, figure out 5A plus 2B instead of having to copy down the whole thing. So I just expanded it for you. I wrote it down below. I want you to try the next two. So that one we just did, we call 1. I want you to try 2 and 3 for me. Copy them down, do them in your book. One hint that I'll give, this is important. This and the presence of these is my hint. So this does change something. It does matter. Take that into consideration. Do your like terms. Make sure you write your answer in standard form. Let's go back to our answer for number 1. This is in standard form. Why? Not only is everything cleaned up, but it's also in descending exponent order. So we have x cubed, we have x, and then we have a constant on that. So clean it up as much as you can and make sure you write your answer in standard form. Copy them down, try it out. Even if you're not like 100% sure how to do it, still copy it and give it a shot, and we'll see how you did. We'll say 2-3 minutes. Also, don't do this now, but in 2 or 3 minutes. If you want to write your answer in the chat, you can. Again, don't do it now, but in a few minutes, I'll ask. When you're writing exponents, when you're doing exponents, you could just use, I call it the caret, this little symbol. If you're ever typing and you want to quickly do an exponent, just use a little caret button. Don't type your answers in the chat yet. We are going to go around roughly to 10:30 today. So around another 25 minutes or so. I did want to get some multiplying. And like I said, towards the end, I'll do a quick little demo with Delta Math again. I'll post a little assignment this way you could practice some of the things that we talked about today. If you didn't sign up yet, not a big deal. You can still sign up. For people that signed up last week, I did have like little demo, what do you want to call it, practice assignments up there. And those weren't like assignments. First of all, nothing over the summer is graded. It's not like you get homework or anything like that. But this way you could have played around with it and tested it out. For those people that did you like Delta Math? Did you encounter any problems? It's kind of user friendly, I would say. Some people tend to not like a few things with it. Like I said, I think there's a lot of pros. Some things I would agree, like once in a while I'll post an assignment and we'll realize after like, oh, they asked kind of like a few weird examples or something. But I think it has a lot of pros. Gives you immediate feedback. All right, yeah, let's go over the answers here. So I gave a little hint, which was, this came up with the first one as well, but just there's no number here. That I said this means something, right? There's some significance here. Can anyone tell us what you had to do with that? You actually had to distribute here. Now, it's not like a distribution where you would need to grab a calculator, but you had to, we call this distribute the negative. Yeah, I call this distributing the negative. So basically, and it's just really a -1. So if I say you don't need a calculator, everybody's sign is going to change inside the parentheses. Right? Why are we doing that? First of all, because there's a subtraction outside a set of parentheses, everything inside of it is being subtracted, which means everybody's sign is going to, like an on-off switch, is going to switch over. So that negative is going to become positive, the -6 is going to become +6, the +7 is going to become -7. I like to write that down too, rather than trying to do too much, right? That's where we start making mistakes. So Now combining, we'll get 3x squared and 2x squared gives us 5x squared. 5x and 6x gives us 11x. And -6 and -7. Be careful here. I saw a few people have got like the first two pieces correct and then made a little bit of a mistake with the last piece. That should be -13, -13. -6 -7, -13. The other good news about this year with the graphing calculator, you're always allowed to use calculators. I know last year your teacher might have at some point told you like, hey, you can use them today, you can't use them this day, or maybe that wasn't a thing for you, but you're always allowed to use them. I know early on in the year I'll get a lot of questions like, hey, can we use them today? Can we use them on this quiz or test? There will never be a day where I say like, hey, put your calculators away, you can't use them. So you will always have access to them. And now for number 3, if you made a mistake with number 2 with forgetting to distribute that negative, if you want to try to quickly fix it, go ahead. But I'm going to do that again. Okay. So I'm distributing the negative. Everyone's sign changes. So that 6x squared becomes negative. 3x becomes -3x. 5 becomes -5. And now combining my like terms, I have, once again, I'm starting with my highest exponent, right? I know that's going to be my first term. Why not start with that rather than just randomly pick one? That's going to be -4x squared. 6x and -3x is going to be +3x. And what's going to happen with the 5s? We have +5, -5. Those are going to cancel out. So no constant in my answer. You should get -4x squared plus 3x. So a bunch of people get that correct. So nice job. Okay, not so bad, right? We just call these polynomial, adding, subtracting. I would say polynomial operations. We're going to quickly talk about multiplying. I wanted to get to that. This way we hit everything. We don't do dividing with polynomials. You do that when you get older. So adding, subtracting, and multiplying we'll finish with today. Questions with this slide before we move on? Good here. Again, just I'm going to zoom in on this last one. Just some vocab. I mentioned this earlier, but in case you missed it, we all know that's an exponent of 2. You could say squared, but we do call this degree. So when you're referring to the degree of your answer, degree means like what was the highest exponent that you had. So in this case, we would call this a second degree polynomial, or degree of 2. Degree is like what was the highest exponent that you had. Another vocab word. This one you know, but maybe not in this context. The number in front of a variable, we usually call, what do we call that? What do you call the number in front of a variable? Starts with a C. Coefficient, very good. In this context, we call it the lead coefficient. It's kind of self-explanatory, but what lead coefficient, I think I was spelling that wrong. What lead coefficient is, it's like the coefficient of the very first term, like what starts off your answer. So in this case, we'd say the lead coefficient is -4. We do have another coefficient here of 3, but the lead is the first one, which, like I said, kind of makes sense. How many terms did we have in our final answer? How many terms do we have? 2. 2. Yeah, this is a binomial technically, right? There's 2 terms. If you're confused with terms, the best way that I've ever explained this, terms are separated by a plus or minus sign. So I just wrote a random problem on the bottom. So the addition and subtraction signs act like little barriers. So we have 1, 2, 3 terms. Okay? If you're confused with like what constitutes a term, Like, is 3 a term and x is a separate one, so those are really 2? No, the addition and subtraction sign in a problem is what separates them. Okay, just some random miscellaneous vocab. This actually does come up. And it's not that bad. Surprisingly, there was a question, and there's usually one on the Regents that dealt with something like this. It gave you a polynomial, and there was a few choices like, hey, what's the degree? What's the lead coefficient? So obviously, if you've never seen those words before, if you're not sure what they mean, that could be tricky. But if you know what they are, it's a very simple question. All right. So we'll close today. We have 15 minutes. And this one isn't really that bad. I say that about a lot of things, spoiler alert. But multiply. So we'll talk about how to multiply polynomials together. With this, we use a strategy that's just called box method. I would relate this to, if you remember the first time you did multiplication in elementary school, the back of your notebooks, you'd have those multiplication tables, the little chart, right? It's kind of like that, but we're going to use it with variables. Box method is basically going to be a strategy to help us organize our multiplication, because otherwise this could get kind of chaotic. Notice what's a part of this. We combine like terms. We write our answer in standard form. Some mistakes that could be made here. People forget negatives. That's the case with most things in math, right? You drop a negative sign, you treat it like a positive, forgetting a term when you write your answer. Just to give you a frame of reference here, how many people know what this is? We haven't even done anything, but how many people are like, all right, I know what you're doing here. And I know what you're about to talk about. Okay, a bunch of people, cool. If not, like I said, it's really not that bad. What you can do first, you don't need to, copy the problem or anything. We're going to draw a little box, a little window, I guess, would be a better. It's not a big deal. Doesn't have to be perfect. Don't use a ruler. My hand slipped at the bottom there. It's fine. You're going to draw a little 2x2 box, little Windows logo. If you have to leave, that's fine. If you want to catch the rest of it. And what we're going to do, so I'm going to be doing this example, sorry, 2x plus 5 times 4x minus 6. On the outside of my box, I'm going to write, let me write it and then I'll explain. The terms that I'm multiplying here. So I'm trying to do 2x plus 5 times 4x minus 6. And this is what I was saying earlier, trying to relate it to, I don't know, when you first start doing the multiplication tables, right? Early on in elementary school. Kind of like that. Where you wanted to say like, hey, what's 7 times 8? You looked at that little chart, and inside that box was whatever the answer was. So we're going to be using this kind of like as an organizational tool. You'll get to the point where you could do 2x2s. When I say 2x2, like what we have here, right? A binomial times a binomial. Most people don't. You'll get so comfortable where you don't need to draw this grid, right? However, box method can be expanded for any polynomial. If you were doing a trinomial times another trinomial, you could draw a 3x3 box. You'd have 9 products taking place. Very tricky. Right here, we only have. But like I said, one of the advantages of box method is we can adjust or expand it to any given problem that we're dealing with. Okay. It does not matter where we set them up. So I put 2x plus 5 on the left side. I put 4x minus 6 on top. If for some reason you switched it when you were doing it, that's perfectly fine. Multiplication is commutative, meaning the order does not matter. Okay. And now what we're going to do, just like you did in elementary school, we're going to multiply to figure out what goes in each cell, right? So to figure out what goes, if you could see my little laser pointer, to figure out what goes here, I'm going to be doing 4x times 2x. That's going to tell me what goes in that cell. So what is 4x times 2x? Not 8x, careful, not 8x. 8x squared, 8x squared. 4x times 2x would be 8x squared. Remember our multiplication rule from earlier? X times x would give us x squared. 4 times 2 gives us 8. For the variables, we're really adding together. There's really imaginary ones there. So x times x does give us x squared. Now to the cell to the right of it. I'm looking right here. We have negative 6 times positive 2x. Negative 6 times positive 2x. That would be negative 12x. Once again, signs are important, so I want to make sure that I have a negative 6. If I just put the number 6 there, I'll probably forget that it is a negative or subtraction sign, which is basically taking the place of a negative here. Now I'm looking at the second row. I have 5 times 4x. That's going to be 20x. Even if something's positive, I do like to put a plus sign. This way I don't forget later on. And last but not least, my bottom right is going to be 5 times negative 6. That would be negative 30. 5 times negative 6, negative 30. Now, I've taken care of my 4 products here. Now I'm just going to write my answer in standard form alongside of it. You wouldn't just like circle the box and be like, all right, that's it, I'm done. So my final answer is going to be 8x squared. 20 minus 12 is going to give us 8x, and then minus 30. So I did have some like terms in there. I know I combined them quickly, so I'll go back to that. We had a 20 and we had a minus 12. So combining those two together is what gave me 8. 20 minus 12 is 8. My answer is in standard form. It starts with the highest exponent of 2 and works our way down to the constant. I know that was relatively quick. I'm trying to squeeze in this last topic, but any questions with, and we'll do some practice here in a moment, but any questions first? Like, hey, I don't know how you got that. Questions on how we multiplied here? All pretty fair? All right, why don't you guys try a quick 2 by 2, another one. So copy this one down, set up, or I should say, set up a 2 by 2 grid. Let's have you guys try 8x plus 3 times 2x minus 6. So draw a 2 by 2 grid. No answers in chat, no spoilers in the chat. Try that one out. Set up a 2 by 2 little window. Back when I was in school, they used to teach us using a strategy called FOIL. FOIL is an acronym. It was first, outer, inner, last. Not a great, and the reason why they don't really teach it anymore. FOIL only works for these examples. FOIL was just a reminder of the fact that there's 4 products here. But what's the downside with FOIL? It only works when you have a 2 by 2. What if I want to do a trinomial times a binomial, right? Now all of a sudden we need like a new acronym. So box method is a little bit more preferred because like I said, you could just add columns, you could add rows depending on what you have. While 2 by 2s are the most common and FOIL works for that, it doesn't work for anything else. If you're interested, the first term in each bubble, the outer terms, the inner terms, and the last term in each bubble. It's just like a memory device. I don't know if anyone's heard of FOIL in here, but it's kind of like an outdated strategy. All right, if you have an answer, if you want to type it in the chat, go right ahead. If you want to write your answer in the chat, go for it. Go for it. I set up my little 2x2. Like I said, does it matter where you put the 8x plus 3? Hey, I put it along the side. Hey, I put it up top. No. I'm going to go ahead and fill in my box. I see some right answers, which is nice. Is this strategy super complicated? No, it's not that bad. That's the case with most things this year, guys. You're going to hear me say that a lot throughout the year. There's a lot of things that kind of seem intimidating or seem scary early on, and then once you start doing it, you're like, oh, that wasn't that bad, and oh, that relates to something that I did earlier. Okay, you should have gotten 16x squared. We had negative 48 plus 6, so that's negative 42x, and then minus 18 on the end. Did anyone not get that and they're not sure why? We'll do maybe one more before we close out today. We feel okay with box method? We're good? All right, we're not going to do that one. If you want to do that one, go for it. Well, I keep saying kind of the nice thing about it is we could adjust rows, right? So let's try one where we need to do something more than a 2x2. So we're going to do this one as our last problem. If you want a challenge and you're looking for something extra, if you want to do that one up top. But we're going to do example 3 together. So here we have a trinomial. I have 3 terms multiplied by a binomial. So I have a 3x2. So I'm going to draw a box like this. You could also draw your box like more vertically, 2x3 or 3x2, I suppose, right? Doesn't matter. This is not a square one because we have a 3x2. So I drew, this one does matter where we put things all of a sudden, because obviously I can't put the 3x minus 7 where the trinomial would go. Like I said, if you started drawing this and you drew like the, I guess, what would that be, a 3x2, like the taller version of this, that's perfectly fine. I tend to draw them like this way, I guess, like more of a horizontal, wider version, but the same idea is going to apply. We want to be careful with our exponent rules here. For example, 3x times x squared would give you 3x cubed. We're adding exponents, so 1 plus 2 gives me cubed, or 3. 3x times 5x would give me 15x squared. Okay, 3 times 5, 15. X times x, x squared. All the way on the right, 3x times 2 gives me 6x. 6x. 3 times 2 is 6. The x kind of just glues on here. And now in my second row, negative 7x squared. Again, no math to do, they just kind of glue together. Minus 35x. And then last but not least, minus 14. And here I'm going to start with my highest exponent first. That's going to be 3x cubed. No like terms for him. I do have like terms for squares. I have a negative 7 and a positive 15. Combining those together gives me 8. That's 15 minus 7, or 8x squared. Next, I have negative 35. Should have used a different color here, but you get the idea. Negative 35 plus 6 is going to be negative 29x. Again, sign matters. I'm not doing 35 plus 6 to give me 41. I'm doing negative 35 plus 6 is negative 29. And then minus 14 on the end. Okay. And that's my final answer. I get a 4-term answer. four-termed answer, right? A degree of 3 and a lead coefficient of 3 also. I did want to try one like this, little trinomial times a binomial, 3 by 2. This is where box method really comes in handy. It's really, if you think about it, it's an organizational tool, right? It's helping me. So can you do this without drawing the grid? Obviously you can, right? But you start to lose track of things. You start to drop something, you drop a negative, you forget a number, you forget a product. So at the end of the day, box method does help us organize it. It's also a little bit clearer to see your like terms. They are going to occur on a diagonal like this if they do occur, which is kind of, visually appealing. Just helps us see it a little bit clearer. All right, 10:30 on the dot. Look at that. So we'll pause here. I think I had we got a decent amount done. I always tend to put a little bit more, and we got through mostly everything I wanted to. So for next week, I'll be posting, it's not posted yet, but I will be posting a Delta Math assignment, just practicing some of these ideas that we talked about to recap polynomial operations, we'll call it. Adding, subtracting, exponent rules come into play, right? Topics next week, we're going to talk about equations, inequalities, and more. So, multi-step equations, variables on both sides, things that maybe you didn't do that much of in 6th grade. And then any questions from you guys? Does anyone have any questions today? Do you feel a little bit better? Did you sit here lost for an hour and a half and you're really scared? Probably not, but do we feel okay? Pearl Fang says hi. How do you know Pearl, Iris? Oh, that's your cousin? Oh, cool. Tell her I said hello. Yeah, so hopefully, like I said, you felt okay today. I know I definitely understand, right? I don't just say hey, this is, this is easy. Why are you getting scared for? We're in a 2-year, 2-year advanced class. It can definitely seem overwhelming at times, but like I said earlier, if you get on the train now, you do everything you're supposed to be doing, you do assignments, practice things when I ask you to do them, you're going to do very well. There's no part of this entire year. I won't say that there's no part that's challenging. There's definitely different aspects that are tougher, different aspects that are easier. But there's no part of this year where it's oh man, this is impossible no matter what. So if you put in the effort, you'll do well this year. So don't panic. I know we have a month left of summer. Let's enjoy it. We'll do these little sessions once a week. I'll see everyone again next Tuesday. That's August 13th. I'm going to use the same meeting. I'll link it again. I'm going to turn it off for now. It's in the little banner on the homepage. I'll turn it off for now, but I'll link it again next week, 5-10 minutes before 9 a.m. And I'll see you guys then. I'm going to stop the recording. I'll stay on for an extra minute or so, just if there's people with questions. Let me stop the recording. Hold on.